Hello everyone. Today we are going to talk about something very interesting. It is called as Concolic execution. Concolic execution stands for concrete symbolic execution, and it's a software analysis technique used primarily for automated testing and bug finding. It basically combines the concrete execution, which is running a program with actual inputs, and the symbolic execution, which is tracking the symbolic expression for program variables instead of concrete values. If it seems a mouthful, don't worry too much about it. We are not going to actually go and create a Concolic execution engine. We are just going to use a tool which will allow us to run a program in Concolic execution. And before you ask and start wondering, this can be used for solving Crackmes or finding crashes on your application and things of that sort, right? So that's where it becomes very interesting and useful. And I am going to show the use of a tool called as angr that is a Python module that can be used for concolic execution, and we'll use it for finding a password that we have to find from a crack. Now, the idea behind the whole concolic execution thing is that you start with some input, and then it will take you to down some path on in your application, and there will be failure and abort conditions. If at certain point of time you hit any one of those, then you have reached a conclusion for that path. That conclusion could be either abort or a success. If it is abort, then it will abort that path, and wherever it has found any conditional jumps, that would be if and a while and things of that sort, it will go back and start tracking, making changes in the variable such that it can take the path in the other direction, and it will keep doing that unless it finds a success path or it exhausts all the paths. Now, there are few ways that I can explain how concolic execution works, and I'll try to explain this with what we are seeing on the screen. It starts with a concrete input. The program is run with specific set of input values. For example, x equals 1 and y equals 2, which is the concrete execution. And then the second thing it does is it tracks the symbolic state, which is what I was mentioning about the paths. So alongside the concrete values, the execution engine also tracks symbolic expressions, representing the possible values of variables based on the program's logic. Then it will have path constraints. As the program executes, every conditional branch, that is if x is greater than 0, or if x equals y, or if y is less than 0, any branching condition statement will add a constraint to the path condition. That is a set of logical formulas representing the decision taken. It could be based on what is the address that we have hit, or it could be based on what is the output that we are seeing, and so on and so forth, right? Then there is a systematic exploration, which is after one execution path is completed, the concolic engine systematically negates one of the branch conditions in the path constraint and uses a constraint solver like the SMT solver to generate a new concrete input that will force the program down a different execution path. Right? This is where the intelligence from the script comes. Think about it. If you were brute forcing a password with path execution alone and not using SMT solver, probably even a 5-character word would have taken you half an hour, 1 hour, right? So it becomes a very slow process. And this, I am talking about a Crackme which is probably written in 5 or 10 lines of C code. If you start thinking about huge programs, then how many paths there would be, and how many if else conditions there would be, and how big the input could be. Depending on that, it can even take months together, if not years, if you had to brute force every input to the application, or if you had to manually test every input to the application. Now, so the next step that is done is the process is repeated, exploring as many different paths as possible to maximize code coverage and discover bugs. So why would you want to use concolic execution? One would be to find deep bugs. Now, as I said, manually you cannot test every possible input to the application. So there, you have to find a way so that you can start testing for things that you have not been able to test manually, or which covers the cases that you are not able to cover manually. Secondly, you can even use it to generate automated test generation. If you are not even using it for execution, at least you can use it for generating the test cases that you can test manually. And thirdly, it can actually handle complex programs quite well. And it can give you quite good test cases or quite good coverage if you are running the program with concolic execution. And it avoids some of the scalability issues of your symbolic execution, which is path explosion. And just in case you didn't know path explosion is, as I mentioned, every if condition will add, if will basically double the number of paths that you have to execute, right? And not just increase it by one. Because every downstream after the if will have four ways to go or two ways to go, depending on how you look at it. And hence, if you have multiple if conditions one after another, it will lead to multiple paths and probably so many paths that you can never cover all the paths. And this is what is called as path explosion. Simple example of concolic execution is you sorry you have a function foo with takes two variables x and y, and it has two if conditions x is greater than 0 or x equals y, and you want to reach here, right? So what will happen is it will start with the concrete execution, which is x equals 1 or y equals 1. It could be any value. It's just a matter of taking one value and ensuring that you are covering all the cases, right? Now, symbolically, it will start taking constraints. After the first x equals greater 0, the second is y equals x. To explore new path, it will negate the last constraint, which is y is equal to not x, with x is equal to greater than 0, right? And then it will use a solver to pick, which will say that x equals 1, y equals 3 for the next run, and so on and so forth. Now, this will keep repeating until you find the constraint and explore all the paths. And there are multiple tools that can be used. There is Klee, Sage, Angr, Crest. I have not tried all others. I have mostly tried with angr. I have tried with few programs and it works quite well. Though sometimes if you do not, and mostly initially you will not understand how it works, then it takes some time to figure out how to use the right API from angr and get some things working. Especially if the binaries are uh, compressed with UPX, then it might not work because the binaries change their code after the binary starts execution. So it's not very good at doing that. But you can always decompress it before you start using angr on it. So there are few limitations. Again, path explosion can still happen. Constraint solving complexity can be too high for the solver to solve it, or there could be external calls, which is interactions with the environments, files, networks, which can complicate the analysis. Sometimes, if there is a network communication, the other side might respond in ways that you have not expected, and it can complicate the complete analysis and take it into a wrong path. So with all that theory, let's look at how we can use it. So what I am going to do is I will take a Crackme as an example and then try to solve it. And I am again going to ask JAP-GPT to create an angr script for me. So the prompt I have used is I would like to use angr to solve a Crackme with concolic execution. Can you provide a Python script for this and how to run it? Use UV instead of PIP. And if you didn't know, UV is a new package manager for Python, which is probably better than pip, and I have started using it everywhere where I was using pip earlier. So it gives a nice explanation of how you can install dependencies with UV. First, you have to install UV, and then you have to create a VNV and then source and do all these things. I will not be going into all these things. I already have UV installed, and I will show you how to run it with UV. Okay. Then it goes ahead and creates this program. So first it is going to import angr and then the clarify. This is used for creating the flags or the inputs that we are going to pass to the Concolic execution engine, which is angr here. Okay. So as I said earlier, there are few tools which can do Concolic execution, and angr is one of them. And we are going to use angr because it works with Python. So the binary path that is assuming is /crackme, which is fine. If we want, we can change it. If we don't, it's okay. We can move our binary to crackme and it should work. Now, first thing we will do is to create a project, and basically that is in terms of angr, just loading the binary and uh, telling the project about which binary we want to run. Now, keep in mind that we are saying auto load libs equals false. This is very important because if we don't do this, then when the project is getting loaded, it will also try to load all the libs. And as you can understand, some of these libs are very huge. So the number of paths that would come out of these libs will be very huge. So the libs will not be loaded when the binary is loaded by the project. Hence, it will not have any information about all the logic in the libs, and the number of paths will be limited to what you have found in the binary. Then we define the input length. This is the maximum length that we want to try for the input that we are giving to crackme. And then we will create a flag, which is basically by first creating flag chars using clarify.bvs. BVS is bit vector something, and it is basically creating 8 bits, and it is finally creating a flag that can be used as a input to the project. Okay. Now, once that is done, then we need to create a state, which is the initial state for the symbolic execution, and we want to create it for symbolic stdin because we are using stdin as the input for our uh, crackme. So we are creating a state with full init state, and giving the binary path as the args, and stdin we are giving the flag. Now the AI is assuming that we want to remove all the non-printable characters, which is fine, and it is just adding a for condition to remove all the characters which are not between 0x20 and 0x70e. Okay. Once that is done, we are defining the success criteria and the failure criteria. As I mentioned, these are the criteria on basis of which angr will decide whether the path should be continued or whether the path should be aborted. And this it is deciding based on success address here and failure address here. Once that is done, it will create a simulation manager, which is what will basically maintain the state and start, stop, and change the variables for our binary. And we need to give the state that we have created to simulation manager. And then we will start the simulation manager with explore, and we need to provide find and avoid for this. You can give just find or just avoid as well, but find and avoid, giving both criteria is a better option, so that it can avoid a branch as soon as it hits a condition. So our avoid will be the failure address, where as soon as that address is hit, it will immediately avoid that branch and terminate that branch there, and come out of that branch and go back to the next branch. Similarly, if it finds the success address, it will immediately stop and show us the flag that was used to reach the state. Now, the way it does that is, once you start SimExplore, it will keep updating SimMGR variable that we have defined, and if we find that SimMGR.found is true, that means that we have hit the find condition. And then we can say that solution state is simmanager.found 0, and then the solution is solution state.solver.eval flag, which is cast to bytes. That's all we are doing here, but as you can understand, in a crackme generally you will not have a success address and a failure address. So we are going to make a small change to this script. So what we are going to do is I am again going to ask ChatGPT. I am going to give the same prompt to it. But what I am going to do is I will just say, I know the success and failure strings. The strings part is most important because I want to ensure that I don't have to deal with addresses, right? If I can avoid doing that. Let's look at the script again. We can see that it is still doing the same thing. Clarify angr, it is importing, then it is defining the success string and failure strings, creating the symbolic bivector for the input, and then it is creating an initial state which is similar. Then it is removing the non-printable characters. Then it is setting up a simulation manager. Earlier we didn't have this. Now we have this where it is saying that if successful is successful is success, it will return true when success string is found in state.posix.dumps1, and it should abort if failure string is found in the same state.posix.dumps. So in find, rather than now giving the failure and success addresses, we are passing the function names that should be executed to return true and false. Rest of the other things remain same. So this looks good enough to get started. So let's try this. And I will just copy this. And I will paste it in a new script. Okay. Now we want to run it with UV. So I will just say UV run minus minus script and s.py. As expected, it should fail because there is no angr. So first we need to install angr, and installing dependencies with angr is quite simple. All I have to do is uv add minus minus script, and then I can say what I want to add. First I want to add angr, and then I want to add clarify. Okay. Now what this does is it doesn't actually install the dependencies, right? So it is only adding a pep comment on top of the script, which defines what Python version is required and what are the dependencies required to run the script. Okay. Now UV understands this comment. So when I do a UV run minus minus script s.py, it is basically going to resolve all these dependencies and install the dependencies before it runs the script. Again, it is managing it based on the script names, and it is also maintaining it globally. So you don't have to worry about any of this those things. But now that the script is run, we can see that the no solution is found, and I probably know what could be the possibility, and let's fix that first, right? So the first thing is we are saying the success string to be correct and the failure string to be wrong. We don't know whether that is true or not. So let's try to fix that. I will just run strings on Crackme. And as soon as you start seeing things like this dot text, fini, raw data, dynamic data, BSS comment, immediately it stands out like a C program compiled with probably GCC. And these are basically saying on programs compiled with GCC, right? And main is a definite giveaway that this is a C program. Now, we just want to see if we can find the success and the abort conditions for this. Okay, here we can see this. We can see that there is a enter password and there is a error reading input. This is probably handling the error condition if the user did not give an input. And then there is access granted and access denied. So I am hoping that these are the two success and avoid criteria for us. And we can quickly verify that by running Crackme. It will ask for a password. We will just give something, and we can see that we are getting access denied, right? So this is what we want to change. So I'll change this s.py, come to this, and we will change this success criteria to granted, and the failure string to denied. Okay. Now that we have fixed this, let's run the script once more time. And we still get a no solution found. This probably one of the things that we have done is, we have removed some of the characters and we don't know what characters the Crackme is expecting. So I will remove this condition where it was removing the non-printable characters. Okay, and let's try to run this again. And bingo, we get .r data. And after this, we have a lot of null characters. Actually, let me quickly see if we can fix this. But even if we don't fix it, it's fine. We know that .r data is the solution for this crack me, because /0 is a null character in /0 is a null character in C. The input length is 20. I guess we should probably try with 10 or 8 or something like that, and probably it might help fix this, right? No, I can still see that is there, but that's okay. We can immediately see that .r data is the string that is being used, and then these are null characters, which is string terminator in C. So we should be able to now run crack me and just type .r data, and access should be granted to us. Okay, so this works now. We know this works. Let's also verify this with Ghidra. If you don't know, Ghidra is a very well-known RE tool, and I have already opened Ghidra, and I have opened it, analyzed it, and kept everything ready so that we don't waste time on this. But as you can see in the main program, this is basically doing the exact same thing that we expected it to do. It is doing a fget in a variable, and then if the variable is just null, then it is saying that it is there is an error in reading input, and then it does a copy of /r/n at the end of local 78, and then a /0 at the end, and then it is doing a string compare with .r data. So this is the key that we are looking for, as we also verified from angr. So that's all I had for today, and this is not the only thing that angr can do. As you could realize from what I have been explaining, this is probably not even the tip of the iceberg. There is a lot more things that you can do. You can explore for crashes, you can explore a huge binary to figure out what input you can give to reach a specific condition in the binary, and so on and so forth, right? Sky is the limit, but you also need to go through the documentation of angr to understand how to use the various APIs from angr to use it effectively. So I will leave you with this thought, and happy hacking. Thank you.